Hey everyone, welcome back. Today we will be solving Leetcode problem number 2402, meeting rooms, third part. So here we are given an integer n and there are n rooms that are numbered from 0 to n minus 1. So we are also given a 2D integer array called meetings where each meeting is represented by a pair start and end. And one more important details mentioned in the problem is that meetings are non-inclusive at the end time. That means if one meeting ends at time t, another meeting is allowed to start exactly at that time t without any overlap. Also, all the meeting start times are unique, which becomes a very important detail later. And each meeting must be assigned to the unused room with the smallest room number. For example, the very first meeting will always go to room number 0. This rule alone tells us the meetings may not be sorted initially, so we should start them by the given start time before processing. And if there are no available rooms, the meeting will be delayed until the room becomes free. The delayed meeting should have the same duration as the original meeting. So what it means is if a meeting was supposed to run from the time 5 to 10 and it gets delayed by 3 units, it will instead run from 8 to 13. Also, if multiple meetings are waiting, the one with the earliest original start time gets priority since we are already processing meetings in sorted order. This works out naturally. First, then we have to return the room with the lowest number. To solve this problem efficiently, we simulate the entire process. We need to track which rooms are available and which rooms are currently in use. So to do this, we use heaps. So before understanding how we can use heaps to solve this question, let us first understand the example that has been given here. So here n is equals to 2, which means there are 2 rooms. So here when time t is equals to 0, the first meeting starts. Since both the meeting rooms are available, the meeting starts in room number 0, so 0 to 10. And when t is equals to 1, the second meeting starts in room number 1, which is 1 to 5. So when t is equals to 2, since both the meeting rooms are occupied and has not yet ended yet, the meeting is delayed. So 2, 7 becomes 3, 8. Similar thing happens when t is equals to 3, 4, 9, and the meetings are not over yet. So when t is equals to 4 also similar thing happens, and when t is equals to 5, the meeting in room number 1 gets completed. So this third meeting that was set to happen when t is equals to 2 gets postponed and starts happening at t is equals to 5 and is set to end at t is equals to 10. So the next meeting, which will happen when t is equals to 10, both the meeting rooms are free. So it will happen at the lowest index room number, which is room number 0. So at the end, room number 0 will have had 2 meetings and the room number 1 will have had 2 meetings. So since 0 is the lowest index, we return 0. So now let's try to understand the intuition behind the optimized mean heap solution. So first, we process each meeting in order. The first thing we do is to free up the rooms. While the earliest ending meeting in the used heap ends or before the current meeting start time, we pop it and push it in the room number back into the available heap. Now we check if a room is available. If it is, we assign the meeting to that room immediately. If no rooms are available, we take the room whose meeting finishes the earliest. We pop it from the used heap, delay the current meeting to that end time, and compute a new end time using the original duration. That room then becomes available for this delayed meeting. Once a room is chosen, we push the new end time and the new room number into the used heap and increment the meeting count for that room. We repeat this process for every meeting. After all the meetings are scheduled, we simply look at the meeting count array. We find the maximum value and return the smallest index that has the maximum count that gives us the correct room number. So in terms of complexity, sorting the meeting takes O of m log m, where m is the number of meetings. Each heap operation takes O log of n, and since every meeting is pushed and popped at a constant number of time, the total time complexity is O m log of n. The space complexity is O of n for the heaps and counters. So that is the full idea behind the solution. Now let's start coding. Okay, now let's understand the code that I've written in Java. Alright, so let's start by sorting the meetings array by the start time. We do this because meetings are not guaranteed to be sorted, and processing them in chronological order would make the simulation much easier. So we are sorting here. Now then I'm going to create two priority queues. The first one is called available, and this is the min heap that stores the room numbers. This ensures we always pick the smallest available room number exactly as the problem requires. The second heap is called used. This heap stores the pairs of end time and room number, and it's also a min heap ordered by the end time. This helps us quickly figure out which meeting finishes first. Next, I will create an array that's called count. This keeps track of how many meetings each room is used for. Initially, all the rooms are available, so I push all room numbers from 0 to n-1 into the available heap. Now then, let's process each meeting one by one. For every meeting, I extracted the start and end time. Before scheduling the meeting, I first free up any rooms that are done, while the earliest ending meeting finishes before or exactly at the current start time. I pop it from the used heap and move the room back into the available heap. Now comes the very important edge case. If there are no available rooms, that means the meeting has to be delayed. So I pop the meeting that finishes the earliest from the used heap. The meeting will start at the end time, and since the duration must remain the same, I calculate the new end time using new end is equal to old end time plus duration. At this point, I know for sure that at least one room is available. So I pop the smallest room number from the available heap, assign the meeting to it, and push the end time and room number into the used heap. I also increment the meeting count for that room. After processing all meetings, the last step is very simple. I iterate through the count array and find the room that hosted the maximum number of meetings. If there's a tie, returning the smallest room number happens naturally because we scan from left to right. So that's all for solution, and thanks for watching.